Okay, this is 8th grade 4.4b lesson. The objective, students will compare proportional relationships and functions. The standard covered in this lesson are 8EE5 and 8F2. The page numbers out of the hardcover book are pages 173A and B. That's where I grabbed most of the activity or the examples for this lesson. And then your practice journal page you'll actually be using for homework. That's page 92AB. Okay, so in this lesson, we're going to be comparing rates. So here is an example. It says the distance y in meters traveled by a 4-person ski lift in x seconds is represented by the equation y equals 2.5x. So what that is meaning is that for every second for x, it's going to travel 2.5 meters. So in 2 seconds, you would go 2.5 times 2 and so forth, okay? So now it says the graph, because they're giving us a graph to line already, shows the distance traveled by a 2-person ski lift. We're going to go ahead and write our equation for that 2-person ski lift, and we notice that it crosses at 0, so in the end it would be plus 0, so we're actually going to leave that off. Our y equals, remember this is our slope, is that number that goes with the x, so our slope is our rise, which was 8, over our run, which was 4, so our slope was 8 over 4. Which when we reduce that down becomes 2. Okay, so there's our two equations. The 2-person ski lift can travel 2 meters per second, or 2x, and the 4-person ski lift can travel 2.5 meters per second, or 2.5x. So it says, which ski lift is faster? Well, if I can travel 2 meters per second versus 2.5 meters per second, well, the one that has the bigger number is going to be faster. So that would be a 4-person ski lift. Okay, if you couldn't get that from the equation, well, we can go ahead and actually graph it out because they're going to want us to do that anyway. So letter B says graph the equation that represents the 4-person ski lift in the same coordinate plane as the 2-person. Compare the steepness of the graph. What does this mean in context of the problem? So if I were to pick, I'm going to go ahead and pick, I don't know, like 4 different x's. So we'll do 0. Okay, so if I do 0, 2.5 times 0 is going to give me 0. Okay, if I do 1, 2.5 times 1 is going to give me 2.5. So over to 1 up to 2.5. Okay, and every box there is worth 2. So I need to be about 1/4 of the way up the box. If I now go in at 2 seconds, so 2.5 times 2 is going to give me 5. So over to 2 up to 5, so the middle. And then we'll go ahead and do 3. So 2.5 times 3 is going to give me 7.5, so just under the 8. Okay, so you can see just from graphing this out, okay, that my graph would continue in that manner. Okay, that is a linear graph. You'll notice linear, our equation was in the y equals format with only either multiplying with addition or subtraction, or in this case, it only had multiplication involved, but there was no squared or absolute value. So we did end up with a straight line. So the question is asking when we compare the steepness, that's our slope. When we compare those, but just visually looking at that, what does it mean when you've got something that's steeper? Well, in this case, because we're talking about the movement of this ski lift, that ski lift in the red line is actually faster. Okay, so our red line was our 4-person ski lift. So our 4-person ski lift was actually faster. So it was showing us the speed or the rate of change. Okay, so let's go ahead and try another one. So here it says at a track event, the distance y traveled by student A is in x seconds is represented by the equation y equals 7x. So in other words, this person A is traveling 7 meters per second, okay, because they told us it was meters. That's how I know it's meters. Okay, so then it says the graph shows the distance traveled by student B. Which student is faster? Okay, so student B, first of all, let's figure out what student B's equation is. Okay, so student B, well, we've got our y equals, maybe I should do it like this. And their rate of change was rise of 24 over the run of 3. So 24 over 3 changes to 8x, and it still is going to be crossing at 0 because we always will start with 0 seconds when they start a race, right? Okay, so which one's faster? Which one was able to cover more space in a single second? Well, that would be student B. Okay, graph the equation that represents student A on the same coordinate plane. Compare the steepness of the graph. What does it mean in context to the problem? So we're going to go ahead and graph our student A, which I'm going to go ahead and do that in blue. Okay, so they're going to change every second 7 meters. So at 0 seconds, they're going to cover 0 meters. At 1 second, they're going to be at 7 meters, so somewhere underneath there. At 2 seconds, they're going to be at 14 meters. At 3 seconds, they're going to be at what, 21 meters? And I'm kind of guesstimating where these are because they set up the graph to work perfectly with student B every 8 seconds. At 4 seconds, 4 times 7 is going to give me 28. So 28 meters is probably right in the middle here. Okay, so now we can see that when I go through and I draw my line through these, okay, that I still have a linear function. But once again, student A, which is, I guess, the red line that I used instead of the blue, that this person is actually slower. They were running at a slower pace. They didn't get as far as person B did in the same amount of time. Okay, so that's comparing rates. So let's go ahead and try one more. So this one's kind of a weird scenario. So it says toenails grow about 13 millimeters per year. So your toenails are going to grow 13 millimeters per year. The table shows fingernail growth. So we have nothing on our graph here. We're going to have to actually go ahead and set up our graph. So you're going to do the same thing that I'm doing on yours. If you want to use your coordinate plane, you could go ahead and do that. The problem is you're going to have to change your Y-intercepts. Otherwise, I think you've got a graph similar to this on the back side or within ones that we've done earlier this year. So here's the first thing that we have to understand is one of these is representing per year. And this one, our fingernail growth, is per week, okay? So we need to be graphing the same information, either per week or per year. Because the fingernail growth was done per week, let's go ahead and set up our toenail growth then also per week. Toenails just gross me out, so. Okay, so if we go through and we figure out 13 millimeters per year, well, there's 52 weeks in a year. So let's go ahead and take 13 millimeters and divide that by 52. And when we do that, it gives me 0.25 millimeters per week. Okay, so that's the first thing, is understanding that if we're using the same graph to represent two different pieces of information, we have to be using the same units. Okay, the fingernail growth they did do in millimeters, so we don't have to do any converting there. So I'm going to go ahead and do my fingernail growth in red. Okay, so fingernails we'll do week 1, 2, 3, 4. This is 0. And I'm just going to do each box worth 0.5 to try and make it a little bit easier for us to see the change. So if this is 0.5, then this would be 1.0 and 1.5 and 2.0, 2.5, 3.0 and 3.5, 4.0, and this is what, millimeters. Okay, so our fingernails are going to be our red. So at week 0, it's 0 millimeters. And I should put weeks down here. Okay, at week 1, well, over to 1, up to 0.7. Over to 2, up to 1.4. Over to 3, up to 2.1. And over to 4, up to 2.8. Okay, we'll notice that everything was changing linear, 0.7 per week. Okay, so I'll go ahead and do my line. Okay, so there's my fingernail growth. So now I'm going to go ahead and figure out toenails. So for toenail growth, okay, so each week it changes 0.25. So at week 1, it would be 0.25. And at week 2, we would be 0.5 because it's 0.25 per week or 0.25x if that's how you want to look at it. Okay, so then at week 3, it'd be 0.25 times 3, which would give me 0.75, or each week we're just adding 0.5. So then at week 4, it would be 1.0 or 1 millimeter. Okay, so we're going to go ahead and just graph out through 4 weeks and then extend our line. So at week 0, it's 0. At week 1, it'd be 0.25, so that's half of a box. At week 2, it would be 0.5. At week 3, it would be 0.75, or the middle of our box. And at week 4, it'd be 1 millimeter. Okay, and we could continue in that pattern, but once again, it is a linear function showing it's changing constantly each week. Okay, so there's our graphs. So it says graph the equations, which we did. They want us to go ahead and identify, do fingernails or toenails grow faster? Well, you can see here that our red line went up dramatically faster, and that was our fingernails. So fingernails actually grow faster than your toenails. Okay, compare the steepness of the graph. What does that mean in context of the problem? Well, it's just showing us the speed or the rate of change. Okay, so once again, this whole lesson was just working with some linear equations and comparing 2 different scenarios. Key thing, make sure that when you're setting up your graphs, that you are graphing the same units. So in this one, I had to change so that I was doing millimeters per week and not per year. Okay, other than that, good luck with this.